Hi everyone, I'm Juby. I want to welcome you all to the August meetup of Women in Compilers and Tools. In the past, we have had speakers come and talk about compilers, specifically about optimizations, some debugging techniques, and sharing their journey all the way. In the past 30 years also, we have had one such speaker. But today, it's very exciting. I'm very excited to see another angle in the PL area, where we have two amazing speakers, Lisa Huang and Ayana Monroe. They are going to talk about how HCI techniques can be applied in PL research. And I would let Lisa and Ayana introduce themselves. They have done a lot of amazing work, and I'm so glad to have met them in Microsoft Research this summer. Welcome, Lisa and Ayana.
Thank you, Juby. Let me start sharing my screen and present. Let me make some adjustment real quick. Hide. Yes. All right. Can you all see my slide? Can't see everyone, so thumbs up. No, yes. Not thumbs up. Say yes. Yes. Thank you.
Yes.
Okay.
Looks good.
Yeah. Hello, everyone. My name is Ranchen Lisa Huang, and today I'm very excited to present with Ayana on our research project on user-enhanced learning experience of symbolic logic solving. And I want to highlight that this research is part of our internship project this summer at Microsoft Research, mentored by our wonderful mentors, Nikolai Bjorner and Peli Diallo, with the research and software engineering group. So I like to start with a brief intro of myself. Outside of my Microsoft Research internship, I'm also a third-year PhD student in computer science at the University of California, San Diego. I'm affiliated with the Programming Systems Group, and I'm advised by my wonderful advisor, Soren. Hi, Soren. I see you there. My general research interests are in the design and implementation of programming languages, tools, and interfaces. And I'm also really interested in human-computer interaction in the context of programming.
Yeah, so that's me. My name is Ayana Monroe, and I'm a senior majoring in information science and computer science at UNC Chapel Hill. And so I'm advised by two really awesome professors. The first is Rob Capra at UNC, working on sort of information retrieval and like search systems. And the second is Dr. Kelly Kane at Clemson, where I'm an RU student working at the intersection of journalism and HCI. And as a result, my interests are kind of all over the place. So I'm really into HCI, journalism, provenance and transparency in sort of a journalistic context, and also information retrieval and HCI and programming as a result of the internship this summer. So this is sort of the first part of the presentation. We've already introduced ourselves. We're about to go into what symbolic logic solving, Z3, and their applications are. We're going to talk about Rise for Fun and also the research questions that sort of outline the second part of our presentation. And so we can start with what symbolic logic solving is. Essentially, the formal definition is solving logical sentences constructed into a formal system consisted of primitive symbols, combinations of these systems, axioms, and rules of inference, but that's really long. But the really simple way to think about it is essentially you have a scenario, you have constraints, and then basically you find solutions that satisfy the constraints that you've set up, right? And so the piece in the middle is what do you use to actually solve for these constraints? And the answer to that is an SMT solver, right? So there are two scenarios that I have here to sort of give a high level explanation of what it is. You can see a grocery list and a picture of a wedding. What does it have to do with everything? So for the grocery list example, you can pretty much think of a good way to think about it is if you have things that you need to buy, we all do, right? But you have a budget. You can think of your budget as one of your constraints and things that you have to buy on your list, the sort of like bread and butter, maybe bread and butter items that are on your grocery list that you pretty much need to get every time you go, right? So for me, I need to make sure that I get salmon and chicken. Those are my main proteins. And then a couple of vegetables that like I know go with everything. So those are my constraints. Those are things that I definitely need. But then, you know, I have maybe, let's say, $200 between me and my roommate to split on food. There's some extra room to go get extra stuff, right? So then you can go in and say, okay, based on the constraints I have, things I have to buy, my budget, what are some, how can I basically switch some things around? What else works basically make sure that I get the biggest bang for my buck with my budget. That's one example of how you can use an SMT solver. If I chose to, I could write up a way to pretty much formalize a grocery list today if I chose. And the second example is a little more, less everyday, more once in a lifetime, hopefully. Let's say for a wedding, you have your reception dinner. And if you know anything about reception dinners, it's the whole thing that happens after you say your vows. Nobody objects to you and your partner getting married, right? The tables that you set up for the dinner, one constraint that you have is essentially maybe two people that really don't get along cannot sit at this table, period. That just can't happen. Or if you don't have a kiddie table, you really want the parents to have a hold on their children. So they need to sit at one specific table together. Those are constraints that you can have. And then you have your entire guest list that you can type everything up in an SMT solver and figure out an actual seating chart that basically meets all of those constraints. So those are some two very intuitive ways to think about SMT solvers in everyday life that are kind of fun. But they're also able to be applied to different industries, which we're going to talk about in a second. But for the SMT solver piece, we can think about basically that blank there. What we're going to talk about is Z3, which is the programming language that our mentor, Nikolai, and a couple other folks in the RISE group actually created to solve these scenarios plus constraints to find satisfiable answers. And so Z3, state of the art, I think that's fair to say, state of the art solver. And you can use it to do things like, the example we have on the next slide is like a plane. So you can verify and make sure that the software you use on really high consequential systems actually works. And so that picture there is of a Boeing 737. And they found an error on some of the software where basically if there was an integer overflow, the plane would lose power in the air essentially and crash. Luckily, it was caught before it ever happened. But if they had ran their software through an actual SMT solver, they would have seen that that was something that needed actually control for. It never happened. I think I'm 99% sure that didn't happen. So thank God. But yeah, something that could have definitely been avoided very easily. Compilers are also another place that we can use solvers. And so basically you can run compiler code through a solver to make sure that everything works as expected. Sometimes you can find really interesting errors, or not errors, but really interesting outcomes that you didn't necessarily expect. That's not my main area, but we had a couple folks come in and talk about how they use it to verify compilers and stuff like that, which is super awesome. And then if you're also working in the networking space, that's a router, but networking in general, you can find very efficient combinations of networks and stuff with Z3 as well. So all these are very consequential ways that you can apply this. And yeah.
And so you may be wondering, what is Rise for Fun? And Rise for Fun is indeed a web-based environment for you to easily interact with all the tools developed with the Rise group, including Z3, of course, because our mentors are affiliated with the group. And so Rise for Fun was developed, I think, over a decade ago. It was meant for providing a really user-friendly experience, interacting with all these fantastic research software without having to set up local development. And literally, you can take this scenario that we were describing in previous slides in a browser. You don't need to download anything. You don't need to set configuration flags or whatsoever. And it sounds to be a dream that's too good to be true, or too good to stay true. And yes, unfortunately, it was taken down in 2021. So yeah, slightly more than a year ago. And which is, that leads to our summer research project statement here. We are about to reshape the education of symbolic logic solving with Z3 as a case study and to revive Rise for Fun. And for here, you may be wondering, oh, wait a second, isn't it all about reviving Rise for Fun? Why don't we just build a system? And what does it have to do with symbolic solving and Z3? So Ayana will be giving you some more background in terms of the education of symbolic solving in a second. But I want to highlight here that, as we previously introduced, symbolic logic solving can be applied to literally many domains. It could bring many benefits to many people. It should be more well known. So we see the opportunity to make symbolic logic solving more approachable through a web-based platform like Rise for Fun.
Right. And so we're also researchers, right? So one of the things that we pretty much saw when we were looking at like this online environment for this very specialized field, which really shouldn't be super specialized, but it is at the moment. Basically looking into the research, we found that people really don't have a consensus on what should be taught in these sorts of like curriculum involving symbolic solving in general. Like at a very large scale, at least it's not like super easy to find. So that's a pretty large gap. In the space of solvers, people don't really think about how a tool online like this could basically supplement teaching and learning. So there are two tools, and I was looking all summer pretty much to find like a large example of tools that we can like compare Rise for Fun to, sort of adopt certain things from. And the two above here, Dymo and LearnSat, are the only ones that I pretty much found. And I think LearnSat doesn't exist anymore. So again, like a really large like area in this field here. And then Dymo is only like, it'll show you the mathematical steps that you were taking while you sort of write your SAT code. But again, that's not really like helping you like learn. Like it's great if you know how to write it and that can assist you there, but otherwise you're sort of like stuck. And then also the other thing that we like didn't really see is how a tool like Rise for Fun could improve the experience of learning something like this. So it's a sort of niche area that people don't really get exposure to, you know, in classes, like your intro classes, you get maybe a Python or a Java, it's object oriented. This is quite different. So seeing how we can use tools in this space isn't really something that's been covered. So we saw a lot of issues and a lot of gaps. And so we're thinking essentially with this entire project, we can do this, we can revise Rise for Fun in a way that sort of helps other researchers get a grasp on how to do this well. And then also making sure that we do this the right way. We do it properly in a way that actually is supporting people, which led to the research questions that we have on the next slide, which are essentially asking what requirements does the guide need to be met or need to meet in order for Z3 to be incorporated into the teaching of symbolic logic. So what are the benchmarks that needs to meet before it's actually deployed in the classroom, like on a technical basis? How do educators expect their students to use the guide to facilitate their learning? So in that aspect, it's like they're as professors, how can they actually go ahead and use the guide in their classes, right? And then how can we support the learners of Z3? So if there are like very obvious gaps that students really struggle with, we want to be able to fill those in. And so we're going to talk about the methods that we took in a quick second, but those are the main things that we were interested in.
Yeah. So with that, it wraps up the first part of our talk, which is background after background after background. And then let's give a deep dive into some more technical details, the design, implementation, methodology that we adopt to build and improve the new online environment we're about to introduce throughout the summer. And then I'll talk about some more preliminary results that we have found, and then propose future work that we can take with this online environment. So I think it makes sense that we start with the little brief intro of human-computer interaction research methods, or HCI methods, that we adopted throughout the research. But I'm not going to throw like definitions and terms to you because they're boring. Instead, I'm going to walk through a concrete example, like using our own research case to illustrate what kind of methods that we adopted. So here you see 4 heads, there's 4 of us, and we built a prototype initially without anybody's input, like without showing it to anyone. We built a prototype. Okay, but how can we possibly improve the prototype so that its usability reaches the next level? We go out and look for potential users for this prototype, like once it becomes a product. And we interview them. We watch them actually use the tool. And we ask them to fill out a survey in which we specify some more concrete questions asking for their feedback about the prototype. And they give us data, like qualitative data specifically, which are mainly text or transcriptive voice or audio recordings, etc. And from such data, we do one level of aggregation and comes into codes. Codes are literally like common topics mentioned in this like long textual data. And from the codes, we further summarize them up into themes, which are like main takeaways we can conclude out of this iteration. And with the big takeaways, we start and go on to build and to improve our existing product into the existing prototype into the next round of prototype. And then we reiterate, we go to potential actual users again, like interview them, observe them, give them surveys to fill out. And it may be the same people that we interviewed before, maybe it's like different groups of people. But overall, as we expect, there are a lot more like actual users out there for us to look to seek feedback from. And again, they gave us data, we aggregate data into codes, and we summarize themes, takeaways out of the codes. And we repeat. So the loop-like structure of our study in HCI methodology is called iterative design. So it's indeed constantly improving your design over multiple iterations, especially with user input early on in the design process. So you actually incorporate the feedback from your expected potential user very early on as you're still planning out stuff, still like figuring out where to put a specific button. And and then the methodology that we take to collect the data are basically interviews and then observations and surveys, which are very common qualitative research methods in the field of HCI. And then we also do qualitative data analysis because we don't do like measurements, we don't like time people or calculate the rate of correctness of a certain program. And so based on the pure textual qualitative data, we adopted a qualitative analysis method called thematic analysis so that we can aggregate themes out of the qualitative data we get. And by adopting the HCI methodologies I just introduced, we land on our contribution this summer, the new online Z3 guide, which is not just a step up from the old Rise for Fun framework, it's also designed with education scaling in mind. And essentially, we followed 3 design principles showing up on the right of the screen. So first, the new Z3 guide should be easily incorporated into the formal instructions of Z3 as well as symbolic logic solving. And second, it should provide a really pleasant user experience. It should be the interactions with the tool should be fast. It should be just user-friendly. You should not have to wait for an hour before an output comes up. And finally, the tool should be scalable. If you have 10,000 users using it at once, it should not crash. And it should be lightweight. It should not require a user to install anything when trying to use our tool. And we should allow anyone to contribute to the content of this website. And so following these design principles, let me first show you how we implemented the system and then give you a deep dive into how we adopt the iterative design to realize these design principles. So we start with course materials, like tutorial materials written in Markdown, pure Markdown. Nikolai prepared them. I did not write them. I'm not in that stage yet. But so with these Markdown materials of symbolic logic solving, as well as the Z3 framework, we actually parse the Markdown files to look for Z3 related code snippets and code blocks. And we decide to pre-compute the outputs of these Z3 related code snippets using the existing Z3 JavaScript TypeScript bindings, because we determined that if this guide is meant for delivering really fast interactive experience for people as they're like learning about symbolic logic solving, etc., when people see code snippets, like examples, they want to click to see the output. They will, if they see 10 examples on the website, they would click 10 times. So we don't want our users to waste unnecessary time waiting for the output to be computed real time. And we figure that it will just save a lot of time for them if we decide to pre-compute those output during the build process. And so we do the build process, the pre-compute output process during our build. And in addition, we also build a custom editor that handles the interaction user provides with the Z3 related code snippets. And we package everything, send them into Docusaurus, which is a static site generator, which eventually compile everything we have and then turn them into HTML files and to the website that you will see. It's live. And so the user, the black arrows here, I illustrate the build process for our framework. But what about interactivity? Like, how did user interact with our tool, and how do we handle those interactions? So when user interact with the editable programming editors, like with the Z3 snippets, they provide new input. So we take that new input and process through our custom editor, and we send the input to the Z3 JavaScript TypeScript bindings to calculate the new output and then render that output in the front end. And one thing I want to mention is that the Z3 JavaScript and TypeScript bindings comes with Z3 already compiled to WASM. So being able to compute Z3 with WASM allows us to maintain this entire framework and maintain our website 100% client-free, client side. Yes, not client-free, client side. And so now Ayana is going to give you some more in-depth introduction about the first iteration that we conducted to improve the baseline of the implementation.
Right. So first we start with that like very robust implementation that we've done through Docusaurus, which is super cool on its face, like really interesting like way to approach the problem. Wasn't my idea, but it's a good idea to really go about doing that. So first we have the content interviews. And so this was basically the baseline in that iterative process where we're going through and gathering data, applying it to the prototype to improve it, and then going back. This is the first step of sort of gathering, based on those research questions we established, the data to really like kickstart this whole thing off, right? So here we interviewed about 7 professors, and we pretty much went through and asked them, you know, again, what are the baseline necessities that you need when you're using a tool like Rise for Fun? One of the things here is that a lot of people used it in the classroom and were really upset when it was deprecated because of the speed and security issues that it had. So we were able to draw on those experiences and like think about, you know, when you were using it, even though it did have its issues, what was, you know, the real things that you really want to see, number one, back, and then number two, what were the things that really hindered it it wasn't the perfect thing. Nothing's perfect, but it really wasn't great either. So what are the sorts of issues there that we can sort of look at there and sort of address in our first iteration, right? And then we also in these content interviews asked them how we can best serve them. So the issues that they had as educators, like trying to teach this stuff, like this pretty abstract stuff to students that have maybe never seen something like it before. And then also what issues the students really were struggling with when they were talking about or teaching this to students. So either concepts that they really struggled with or ways that they felt they could support their students that was really beneficial. So we gathered all of this up in the first content interview stage with 7 professors, and then we moved into the UI UX stuff after we enhanced the content.
Yeah, so for our second iteration, we focus on the interface and the user experience, especially the programming experience of our website. So we went back to the 7 professors that we interviewed previously, and 4 were able to work out their schedule with us. So we interviewed with those 4 professors from the previous study and asked them to extensively use our website from 2 perspectives. Perspective of their own and perspective from their students. So they actually did some role playing. And so they actually used the website thoroughly from the teachers and the learners' perspectives. And throughout the process, we're able to identify like several usability problems that we need to address for the next iteration of design. And I want to also make a comment on the n=4 sample size here, because people might be wondering, wait, isn't it like 4 people too few for like finding any significant observations? And here I want to point out that in the literature of usability testing, it shows like 5 experts are already enough for identify like about 70% of especially severe usability problems. And yes, we here only have 4, we don't have 5, but we have like surprisingly 1 more expert that we exclude from like the formal interviews, but the one expert is Nikolai himself. He was not involved in the implementation framework engineering at all. He was just actually actively using the website to add content, to improve content, and then really go on to try out examples and so on. And then based on his like day-to-day work doing such, he was able to identify a lot of usability problems as well. So with such feedback, we land on the next iteration of enhanced design, and we conducted an online Z3 learning workshop where participants learn about symbolic logic solving and Z3 using our tool. And the workshop was meant for both evaluating the previous rounds of design, as well as for collecting more feedback for us to prepare for future rounds of iterations. And fun fact, the workshop was held yesterday. So we got 112 participants. Not all stayed the entire time, but based on the record, there are 112 joined yesterday. And although we have not started like actual formal analysis of the post-workshop survey data we collected, I was just scamming through the ratings and the feedback, and they look overwhelmingly good. And so now Ayana is going to show you some more general preliminary findings we have from this entire iterative design process.
Yeah, so these couple slides are sort of a result of the scanning that we've done of everything down from the content interviews to the workshop that we had yesterday. Just want to clarify that this is not like with the thematic coding and everything, like it's not the full like data analysis yet. But these are sort of the results that we have so far. And they're sort of grouped by, again, our research questions. So the requirements, supporting educators, and then supporting learners. Everything you see here that's sort of grayed out is what we found most surprising. So when we go to the next slide, we're going to talk about, like we're going to go through everything quickly, and then also the things that we found most surprising. So here, so starting first with the Z3 guide requirements, we pretty much see some things that make sense. Nothing really super shocking here, but people really want to see input and output history. So you're making incremental changes to try and get better results for code that you're running. People want to make sure they're not repeating the same thing over and over again. So just seeing, you know, based on what they put in, what they get out, and then from there, they can do a better job of, you know, writing code and finding a better solution. Then we have it being fast and stable. As we talked about, one of the main reasons that the Rise for Fun was deprecated was that it would crash all the time. There was only like one server supporting several classes that were using it at the same time and trying to learn on the web on the fly. It didn't really work. So people wanted to make sure that that didn't happen. Naturally, it makes sense. People were also really hoping that the progress sharing of some sort would come back. So one of the old features for Rise for Fun that people really liked was the permalink feature. Essentially, you click, you write, maybe you're working on an example with arrays, you make some of your own configuration, something doesn't work, you copy a permalink, send it to somebody and be like, what, why is this not working, right? So that progress sharing feature was something that people really wanted to see, at least some form of it, maybe not permalinks, but some form of progress sharing needed to come back. And then also people really want like the visual IDE like editing, which again makes sense, highlighting certain words, like highlighting errors really efficiently in a way that maybe like a VS Code does. People really want to see that. So all these things really make sense. Where we see this sort of or surprising findings really comes from when you look at the supporting educators piece. So one thing that educators really wanted to see was some sort of way to share resources amongst themselves. One thing about this community is that it's very small. There are a limited amount of people teaching this and researching these sorts of tools and working on that kind of stuff who are also like educators at the same time. So when they're sharing slides and sharing resources and stuff, it's sort of a whisper network. So maybe like Nikolai will make a huge slide deck with 100 slides, and then professor at University X will make a couple edits for his students and then share with maybe a couple friends that he's working with, hey, like I made these edits to Nikolai's slides, like go ahead and share these with your students. And so things kind of get around that way. Everybody knows it's happening, but everybody doesn't have access to the changes that are happening. They just kind of know that they're out there, or maybe they'll reach the slides and they don't know who edited what. So some sort of like way of establishing and sharing these resources in a formal way, not just like through email threads, was something that people really wanted to see. Another thing that's sort of on the same vein is staying tuned to changes in the Z3 ecosystem. So one thing about like Z3 and like working with like SMT solvers in general, is that if you make a new addition to the, like, I don't want to say code base, but if you make something that's sort of an add-on to C3, that'll go on GitHub. And then basically if people are like watching the thread, they'll pretty much be attuned to the update that you've made that they can use in their own work and they can share with their students. So if you have like a way to visually render in a graphical way, some sort of output from Z3, that's great if people are watching the GitHub like ecosystem around Z3. But if they're not attuned to that, they don't follow you on GitHub, maybe they don't know that exists. But then you find out about it later down the line, and then that would have been so useful for last semester, right? So being able to see those sorts of changes and the updates to that ecosystem in a more formal way, again, with the same with sharing resources, was a way that, or an improvement that people really wanted to see supported. And then also one thing that really didn't shock us was people wanted to extend this to their own classes. The Rise for Fun guide is great, but if people want to teach something else based on the ecosystem or based on the content that they're teaching in their class, it'd be really cool if they could like fork the repo and then, write their own content up that they can share with their students. And then we move on to supporting learners. We had a few surprising things here. One thing was competitions. People were talking about how their students really benefited from having competitions in the classroom. So, you have a set of, scenarios that you really want and constraints you need to solve. Seeing who can write solutions to that the most efficient way possible was something that really encouraged students to actually learn how to write better code and that sort of thing. So that was sort of seen as a way to help students learn, and doing that in a community-based fashion where maybe Nikolai posts, hey, we're having a competition, the winners of this competition at like students who are doing this competition will win like a hoodie or something like that, like the fun little thing that could help students or encourage students to participate in the community more. Which is, fun fact, the reason why I made a new logo, which is on another one of the slides, but really not important. And they also highlighted some really things that we expected, like a couple concepts that are like really confusing across the board. We wanted to see like more resources for, better support for in the guide. And then also another thing that's not as surprising is the gamification and visuals piece. Education literature says that students learn a little bit better when there's gamification and more images sort of like on the content that's helping them learn. So that's not all that shocking to see. But the last thing here, as a student who comes from a university where the honor court is like very, very active, I was very shocked to see that professors actually encourage people to ask questions online, and being like, if they, like, office hours are great, but if you have something that you need help with immediately, like, go ahead and ask a question on GitHub. Like, if you can't do well in the exam, that's how I know you cheated, essentially. So encouraging students to ask questions online through the channels that exist right now was something that they wanted to see supported as well. And so that was a lot of data right there. So if we have any questions about that, we can sort of maybe review anything like after the finished presentation, but now we can move on to sort of next steps, what these preliminary results tell us about what we need to do next, right? So it's pretty well established that people really want SMT education accessible, right? As we saw earlier, a lot of these industries that could really benefit from people having an easy access to resources like this instead of scouring the internet, because that's really what you have to do now, scouring the internet and like finding gaps in their knowledge between concepts that are present, like going through research papers, all that stuff we really don't need to do. We should have a guide that really helps people learn and adapt their what they know and the content that they can learn to their industry, right? Another thing that we see here is that knowledge sharing, sort of on the side of educators and learners, is something that we really need to see supported, and helping learners and practitioners sort of discuss with each other, share resources is something that is reflective of the state of the community now, but something that we can support in a formal way. And then the piece that Lisa is going to talk about in a second is sort of Rise and Beyond. So applying this framework that we have here for the guide, having an online editor, so you don't need to install a whole bunch of stuff, how we can apply that to other tools sort of in the Rise ecosystem, but theoretically anybody could adapt.
Yeah, indeed. So our end goal is to revive Rise for Fun, and all we've been talking about now is the online Z3 guide. But what about the online F-star guide? What about the online whatever guide? And then, yes, we indeed want to extend this framework to other Rise tools and even tools beyond Rise, like other programming languages and tools. And you may have a question, like it looks like from your implementation graph, everything's very Z3 specific. So how do you handle potential extensions of this framework to other languages and tools. Here I want to highlight that our framework was designed to be extensible in the first place. So all the interactions with Z3 from this previous slide are actually specified in a language configuration file. So inside the configuration, we specify following information. First, name of your language. Second, where do I find the runtime executable of your language? And also you have to bring in logic in terms of when your input is computed, how do I deal with the output? If there's an error, what kind of error do I want to report? If there's a timeout, what kind of message do I want to deliver to the user, et cetera, et cetera. And basically we take care of the rest. We take care of front-end rendering. We take care of handling the interactivity users have with the website. And you can further build a website using our framework and host it eventually on your GitHub pages. So if one day, I don't know if there are language designers out there in the audience, but if you want to build an online interactive documentation or interactive tutorial guide for your awesome language, then make sure you have a name for your language. Make sure you have, well, not make sure, but it'll be ideal that you have something that is compilable to WASM so that we can ensure everything can be run 100% client side. And let us know how you want to, how your output would be reported to the user in a meaningful way. And there you go. You can build an online interactive documentation for your language. And so tying back to our not super mature, but really potential vision here is indeed to make the process of building online documentation, interactive documentations and online tutorial guides for literally all the programming languages and tools out there easier. And that wraps up our talk. And here I put contact information of both of us if you would like to stay in touch with progress of this project or something more exciting down the road. And if you're interested in learning more about the Z3 guide, I put a QR code here. If you have a mobile device, you can just scan it and then have a Z3 guide on your phone and run Z3 on your phone if you want to. It's doable. Or not. There is a URL that is right here. I can paste in the chat in the bit so that you could just visit it and then see what it looks like in your browser. And now we open the floor to questions.
Thank you so much, Lisa and Anna. This was a really amazing talk. I think I have learned quite a lot about the HCI techniques today. And I think the coolest part was when you actually came back and said that this can actually be, the framework can be reused for other, PL areas as well, which have kind of a similar configuration set up already. So that's really helpful. I would like to welcome our attendees. If they have any questions, please go ahead and just unmute yourself, or if you want to post your question to the chats, and just do that. Do we have somebody? Okay, otherwise I can also get started. I have a lot of questions today, not just about the Z3 guide, but also about, learning in general about how HCI techniques can be applied on PL, or the exciting, even more exciting part is like journalism, which Anna mentioned that she's interested in. But before we dive into all this questions, I first wanted to know about, do you also use Z3 in general? Like, do you come from that kind of a background, or are you just focused on the HCI techniques only while you did all these experiments on Z3 guide?
Was that a question for me or Ayana or both of us?
Yeah, you guys can do either way, or if you want to share your opinions, both of you just, take your.
You can start, Lisa.
Okay, yeah. No, I don't come from that background, like extensively using SMT solvers as such. I gave myself like quick crash courses of SMT solvers by reading Nikolai's papers before I interview with him. and learn about SMT solvers. That's it.
Okay.
Yeah.
Cool. Do you want to give like a quick, example, kind of a demo to our attendees? Maybe, people would be more excited to see like how the Z3 solvers are. Like I have used it for all my work during my PhD, and I find them very exciting.
Yeah, absolutely. Let me share my screen again. So here is like the main page of the online Z3 guide. And as you see, there are three main sections here: the SMT lib tutorial, programming Z3. So some more information about like Z3 and other language APIs, language bindings. But for the demo, I'll go into Playground, which has two sections. The first one is freeform editing. You can just run Z3 program in your browser and render to output, which is the regular kind of interaction you would expect with programming. But I want to do some game, and in this case, to like bring more excitement. So yeah, this is like some activity we developed for the workshop as well, just to trying to cultivate more interaction among the participants. And so the idea is that like here, there is a secret formula behind the scene for each of the code snippets showing here. And your goal is to guess out what is the correct formula based on by constantly checking your input through Z3 and then the output to determine what further assertions that you might want to make for add to your formula. So let me just start with the first example. I'm just declaring a constant, an integer here, and I click check, and I get an output that says, X.
Sorry to interrupt. Can you increase the size? I think people.
Yes. Yeah. Sorry about that. Yeah. Is it better?
Yeah.
Better. Okay. Yeah. So the output I get is here. It tells me that when x equals to 1, satisfy my formula, but it does not match with the secret formula. So I can further ask stuff like I'm gonna assert x equals 1 and see what happens. And it tells me that when x is 0, it does not satisfy my formula, but it satisfies the secret formula. And I'm like, okay, I would just do greater than equal to when x is greater than equal to 0. And it tells me about this -2 counter example. And does anyone see a pattern here? Yet? Not yet. All right, to save time, I'm just gonna throw out the answer. Answer is like this model. The formula is all about finding the even numbers. So you need like mod x by 2 equals to 0. Am I missing something here? Yes, I'm missing the parentheses. And then I get the right formula. Congratulations. So yeah, that is a short demo of games on this website.
That's cool.
Mm-hmm.
Yeah, I remember my time, like when I started to learn, obviously Z3,
Right.
Rise for Fun was the one which kind of gave me this whole walkthrough, and then I started to learn Daphne. So all these tools, came from my Masar, and they're very useful. Yeah, great. Yeah. If anybody else has any questions about the tool or about Z3 Guide, please come forward and ask your questions.
I have a question about the kind of the data collection phase when you like reached out to multiple professors. What like type of like classes and like coursework was taught by those professors and like the kinds of students that they're gearing towards? And kind of my general theme is like what level of like programming expertise or like math expertise should people have coming into learning or like interacting with Rise for Fun?
That is a fantastic question, because it's, to answer the first part of it, the spread of like what is actually being taught and also who is being taught this information is kind of all over the place. You have folks from all the way down to a couple of high school students that some professors are working with in the research area. There's sort of a, can we start people off with learning about like SMT work before they even hop into computer science in general, which is a mind-blowing approach to teaching comp sci. But they did it, wrote a paper on it, which I can share, which is super interesting. all the way up to like an intro, like grad level course, expecting them to have like a lot of logic basis and also programming experience. So the spread is very, very large. I'll say, to answer the second part of what people should know coming in, from what it seems like looking at the entire like 7 professors that we talked to, the main thing that was consistent was pretty much having some basis in knowledge or logic to start with, and also having coded before period. And then from there, they seem to be able to work with the people that were coming in. And in terms of the concepts, some were teaching pure SMT stuff, and some were teaching also compilers and software verification classes. So that's the sort of spread of things that we were working with, or professors are working with, like at different universities. And then I'll say, yeah, for what basic knowledge you need to come in with, yeah, just logic and having coded before, you should be able to hop in. But you know, it is, as somebody who like had that baseline and taught myself Z3 to like do this internship, that was sort of a struggle, because I'd also taken discrete like freshman year, which was a couple years ago now. So like definitely like relearning a lot of stuff on the logic side before hopping into it was like pretty important for me. And also like having Nikolai as a resource was great, but everybody doesn't have Nikolai. So then there's also the sort of bringing in resources that you need on the Rise for Fun page. So if you're coming in from where I was coming in from, you're not like in a very interesting location. So yeah.
Yeah, that makes sense. In my undergrad, I like took a intro to philosophy class, and we learned a little bit of logic in there. And so I would think like using a program like this would be really cool for people, even outside of like the context of like formal math and computer science and stuff.
Yeah, that's a great point. Those concepts are in philosophy, which I didn't realize until one of my friends who is a philosophy minor was like looking at what I was doing, like, oh yeah, that looks familiar. I was like, well, what are you talking about? Like, you go to or like he's trying to go to med school, what? But no, some of those concepts can like definitely be applied and also could be used as a learning tool there as well. Yeah.
Great. Lisa, I have a question for you. Since this talk was, very much tailored towards helping learners and educators to learn the SMT solvers like Z3, we'd be very happy to know if you can get started by sharing the kind of spectrum of your whole research interest and the bigger goals that you aim to achieve through your research.
Yeah, that was a wonderful question. So broadly speaking, my research is in the space of like the usability of programming tools and programming systems in general, because the vision is that if you have a super powerful programming tool that is not usable at all, then regardless of how powerful it is, people are not going to like it. People are not going to use it. Then if nobody is going to use this powerful tool, then how can it possibly deliver its power in the optimized way? So, and then the bigger vision out here is that I hope by building usable programming systems, as well as improving the usability of existing systems, I can one day, like through my effort, to some little extent, make the programming experience more enjoyable for everyone.
Yeah, great. Ayana, I have a similar question for you. So, I was reading your bio and it says quite a lot of things that you're doing. You're majoring in CS, information science, and also focusing on the cognitive psychology. So this is all very amazing. So I wanted to learn more about like, what are the research problems that you are also intending to solve through your research career?
Yes, that's a great question. So it's definitely sort of all over the place for me right now, but at least at the moment, the things that I'm working on really sort of surround and are tangentially related to how we can support like effective decision making, and to sort of like elaborate on some of the stuff that I do at like UNC and Clemson as well. The stuff I do at UNC is related to helping people like search better. And so the whole thing about like searching things that involve steps, there's sort of declarative information, and then there's information that involves like things like recipes or how to like solve formulas and things like that. Those are very more so involved than like what's the capital of Wyoming. I don't know the answer to that question, but like those are two different like areas of research or asking questions. So the work at UNC is involved in actually helping people figure out how to get to those like steps of information and find like the process of information like a lot more easier than it is now. And so like helping people with decision making in that sort of sense. And then also at Clemson, the work I'm doing is involving how do we help people figure out if they can actually trust the news that they're reading. And the short answer to that is there are certain facets that people are really interested in before they want to make a decision. Because unfortunately, fake news and misinformation have sort of made looking at news media a stressful experience for a lot of people. So what information can we give that's available for journalists? So there's things that they don't publish, like changes and sources and things like that, that are accessible, could technically be shown to a user, but they just don't right now because it's never occurred to them to do it, or they've had reasons to not do it. But based on that information, what can we present to users to help them basically decide if that's what they want to trust or not? So both of these things are, helping people make better decisions. That's what I think I'm really interested in now. I'm applying to grad school and trying to find a better, more concise response to that. But at the moment, that's what I like to say that I'm really interested in.
Sure. So yeah, I think I was also curious, like whether you're going to pursue like a grad school after this, or are you planning to go to industry or somewhere else? I think you're going to go to the grad school.
Yeah, I'm applying this year. So if anybody has any tips, I'd love to hear them.
We have, professors today, so I'm sure they will have better tips for you. Yeah, and also like when you said it's about extracting or sharing the useful information which might help people in making better decisions. Does it mean like your techniques kind of try to even validate the information at some level? And I mean, validation is a very bigger and harder question, but I was just curious, like at what level do you do this?
Yeah, so that's a great question because there's two different sides of coming to like the information that actually helps people determine whether or not they want to trust the news that they're reading. And so the larger piece that I didn't say about the work at Clemson is that we're going to have or the goal right now is to have a blockchain that sort of goes through and takes in information. So you have a cryptographic record that can't be changed, right? Like once the journalist makes a decision to change something, that data is like pretty much set in stone. So users have the assurance that, hey, this is what actually happened. This is the change that happened. So, you have a record of any manipulation that happened to this data. So there's validation on that side, which like this work in PL has sort of inspired me to look at like how can we help journalists sort of like get better at that process, because the work that the process that they take now is kind of all over the place depending on what like agencies are looking at. So like a really small organization probably like is not thinking about these things at all, versus like the New York Times, it has like a very intense, robust system for how to actually do these things super well. So there's like the actual like validation piece of the actual journalistic process that has been of interest to me. And then there's like, how do we actually tell people like, hey, we've taken these steps to make sure that the stuff that you're reading has been like thoroughly vetted in a way that like they can see. So both of those angles come into play. And thankfully, I didn't expect to work on PL this summer, but looking at PL and HCI together has sort of made me think about the work I'm doing at Clemson through that lens, which has been very fortunate to me. So
yeah, great. I think I'll circle back again, maybe on this part of the question one more time. But I'll jump on to asking one question to Lisa as well. So she shared her interest in helping programmers and helping computers both ways. So Lisa, would you mind elaborating a little bit more on like what kind of techniques do you use to enhance your whole research all over, and also like how did you land up in the PL research? Where you picked up these kind of problems? Yeah.
Okay.
Like what really motivated you?
So I let me rephrase the questions. Like there are two questions. The first is to maybe elaborate on the research vision I essentially put on my website. Second, how do I land on my PL research?
Yes.
Let me start with the second because the flow looks more natural to me. Sure. The way I landed on PL research is that, so I think it's worth mentioning the other half of my background during undergrad. I was also a double major in cognitive and linguistic sciences. So I was like really into languages, like not programming languages, like human languages in general.
Mhm.
But I was also doing computer science, and PL was a required course for all majors back then. So this day I was sitting in the PL course and learning all about like functional programming, all these other very fantastic paradigms of programming, and which are really fascinating. And as I was sitting in that class, 8:30 in the morning, a thought all of a sudden struck me, like, is that like I learned all these different programming languages, but they're all in English. Why? So that was like the very first moment I started to think about whether there are other non-English programming paradigms that I am not aware of. So like two main reasons behind this question. Like first is I started computer science really late. Second half of my first year, I was a philosophy major, just information here. And so my knowledge about programming is very limited, like all limited to college education. So apparently I did not know of other programming paradigms out there. And second is that I was studying linguistics. I knew a lot about languages. I was also multilingual. I spoke like 4 languages fluently. And so coming from this multilingual background, really every time I see like English only or English primary tools, mechanism, etc., that prompts me the question of why English only? Why not something else? So after that class with this question, I went to the professor's office hour and then asked this question. And from that conversation, I further learned about like all these other non-traditional, not so common, yet really helpful programming paradigms, such as visual programming. And which, so the professor of that class, which eventually became my undergraduate thesis advisor, there are researchers in the space of like block space programming, especially MIT App Inventor's block space programming system. And he had an idea that's been like lying there for 10 years, which is blocks programming is great for novices. But when people, begin to have more like knowledge in programming, they start to complain about the difficulty with moving the blocks around purely through drag and drop using mouse movements. And could there be a textual, bidirectional, like textual representation of the blocks? And he said, well, you are from a language background, and why don't you start working on the syntax? So I said, sure, why not? So I had this small notebook where I kept all the random notes I had for the syntax and semantics of that language. And one day I was jotting down notes, and all of a sudden I realized 2 things. First, I became a language designer. I was literally designing a new language. Second, I was making arbitrary decisions about this language without asking anyone else. I was just making these decisions myself. What if users of my language would not like it? And so coming back to the blocks and text question, because I was supposed to design this language following the already defined principles of the existing blocks. So I said, okay, let's keep the morphism here. I would design my language to be fully braced, which we all know is a pain to write braces in programming environments that don't support auto completion or brace matching, etc. And as I was going through my design, and I started to have the idea that I would like to involve potential actual users of my language early into the design process of this language, and which eventually became part of my thesis project. Undergraduate thesis project, I conducted like 2 rounds of user studies, so also adapted an iterative design. My potential users are like actually high school students. So throughout those studies, I adopted like quantitative approach rather than qualitative approaches. I gave them, there are blocks programs in which they are supposed to translate it in text. And based on their textual solutions, I measure like for each token of the language I wrote out, what is the accuracy for each token? And then later figure out, people made a lot of mistakes on this particular token, on this particular keyword. Maybe it does not make sense to have it there, and then further improve my design. And then also people complain about the braces, and then I sort of developed like syntax highlighting system later to sort of ameliorate the process. But I think I got way too far. But yes, back to the question, how did I got into PL research? Because of my linguistics background, because of my interest in like actual users of language and programming languages, especially. Yeah, and you wanted me to elaborate my research vision a little bit. So I wrote it on my website that my big vision out here is to improve the communication between human and the computer in the context of programming. Because I consider programming to be essentially a communication between two parties, programmer and the computer. So to make the process better, there have to be improvements from both ends, and improvements coming from the human end is very easily understood. That we interact with the computer with multiple different input modalities, like normally through a keyboard and mouse, and with sometimes we have touch screen with our monitor, so we can touch on the monitor as well to interact. But we have all these other available senses out there. We have our voice, we have our hearing and our vision. And is it possible to incorporate some of these senses, to utilize them in a more meaningful way, such that we further enhance the programming experience in a rather unsurprisingly way? So that's like potential improvements we can make on the human end to further improve human programmer-computer collaboration. And then to the computers end, well, you asked me a question a couple of days earlier. You asked like, what does it mean to help the computer? And I answered, helping the computer to deliver its intent in the best comprehensible way to human will eventually help humans to understand what is going on with their program, and if there is an error, how to best adjust their program in order to land on the good optimal solution for whatever they're working on. So the idea is that if we help humans, we're directly helping the humans in the context of programming. If we help the computers, and we're indirectly also helping humans to further improve the programmer-computer interaction. Yeah.
Right. Yeah, no, that's cool. And I think for the PL side of things, you work on some instrumentation technique. Is it more like a binary instrumentation that you do, or is it something different?
It's just I guess it's just instrumentation on the back end, like the runtime information, the rich runtime information available when we're executing a program, and then how do we explicitly extract information out of that context and then make meaningful visualizations to people, and which is widely adopted in technique called live programming, which is essentially immediately visualizing your program state changes to you on every change you make to the program. And yeah, that has been some ongoing work in our group done by me, my advisor Soren, and then my colleague Kasra. They're all in the chat. So
okay,
yeah,
great. Yeah, this is cool. And I would assume like when you actually knock down that problem of designing a language, and then you figured out, oh, there's a need of actually knowing how users think about it, because that's important. If it has to be used, users have to share their opinions. So I presume like you already had the HCI background that actually helped you, build that survey and go through this whole kind of iterative experiment, and whichever techniques that you adopted at that time to study the underlying language.
I mean, by the time I started the PL research, like my undergrad research project, yes and no. It's like yes and no. So my first research experience was actually in HCI. Exactly in the space of information credibility that Ayana super cares about. So I had like very brief research experience in that space in my sophomore year. But in the meantime, I'm also cognitive and linguistic sciences major. So I had to take, it's a very interdisciplinary program. So we are also required to take psychology classes. And through the psychology linguistic classes I learned a lot of, especially qualitative experimental methods that can be really beneficial in HCI research. Because after all, human-computer interaction, this field originates as like from the perspective like psychology, like adopting psychological experimental methods in the study of human factors in computer science.
Agree.
So, sorry to interrupt. I think we had a hand open earlier from Soren, if you'd like to ask your question as well.
Oh, yeah. Hold on, let me just turn this on. Can you hear me?
Yeah, welcome,
So-
Soren.
Oh, yeah. Thank you so much for the talk. That was fantastic. So I had a question about kind of when you build some of these tutoring systems, there's kind of also this trend of building kind of these interactive systems that actually adapt the problems or the lessons based on mistakes you make or kind of what kind of interactions you have with the system. So these kind of smart tutoring systems are, some people look at them. I was wondering if you see a possible use for that in kind of the Z3 system that you built.
I think it's possible. With the help of like maybe, I don't know, reinforcement learning techniques, about which I'm not a specialist to comment on. I said it's possible because I see the potential in the context of esports. Again, I'm not an expert in esports, but I do know that in like video games, computer games, there are systems out there such that if you play really well for 3 days straight, like you win every single competition, somehow the setting for you will adjust a little bit and makes the game to some extent harder without you even realizing. And then after 3 days of winning, you start to lose for 2 days. And then you realize the system is making some changes on me. And so I consider that kind of system behind the scene to be adaptive to the player's behavior, the player's winning and losing history. So I believe like if we adopt that kind of system in the context of online tutoring, then it's totally possible to do adaptive-based smart tutoring systems.
Pretty cool.
All right, thanks.
So, Lisa, I had a question. So you mentioned, I was really fascinated by the organic way that you got into your research topic and this work. So when you started developing this language, it stemmed out of your first question. Does all programming language, why is this an English language paradigm, right? So the language that you designed, so is it a different language?
No, unfortunately, it's also an English language, but I think, if one day it goes into product, then it should support internationalization because App Inventor, the block-based environment, was designed in the first place to take care of I-18. And I think it support, I don't know how many languages support, but at least a ton of major languages spoken out there in the entire world.
Okay.
Yeah.
So unrelated to your earlier comment, right? So one of the other things that you considered was going from this block-based languages to text languages, and you were like, why can't this have a text representation? But isn't that like every language that we have? Like, I think I'm missing a step there in what your question was, like, because most programming languages are text-based, and then later we have like this block-based languages that came up, right? So
yep.
What were you referring to there?
Yeah, that was a good question. So the text-based language I was referring to is essentially a translation, a bidirectional translation of the original MIT App Inventor's blocks language. And so it is meant to be bidirectionally able to be translated like bidirectionally, because there are settings that users might want to use the blocks. There are settings that users might want to use text only, right? If I am working on a project with a colleague, I had a fancy solution on the problem. I want to email them. how am I supposed to email them a set of blocks? And so text in this case could jump in a really helpful way. Like if I translate my docs to text, then I get a text. And vice versa, I am myself's colleague. I received the textual program, and now I want it to be back in blocks because I'm more used to editing in blocks. How do I get from text to blocks? So then enabling the translation from text to blocks is also critical in this user scenario.
Gotcha. It's like a serialization, deserialization kind of thing.
Kind of, yes.
Got it.
Yeah.
Okay, makes sense.
Mhm.
Thank you.
It's a really great question. I haven't commented on that project for a while, so it's great to like refresh my memory.
So we have another question in the chat box from Frank. The question is, do you think you or the RISE group will run courses using on using Z3, working through real problems, or having people bring their own to really dig into how to properly use Z3?
Ayana, we want to comment on this?
Yeah, so that was actually some of the feedback we got. So the workshop that we ran yesterday, a lot of people actually wanted to have, I don't know if Lisa expected this. I don't know if I did, but it was like 3 hours with like a short break, and like a lot of people stuck through it and were really excited about what we did. So people want to see more workshops from us. I don't know about that long, or like that was a lot, but a lot of people stuck with us. So people want to see more workshops. I think that's a really great idea of having real problems and working through it in that way. But one of the things people really wanted to see was like advanced concepts. So we basically went through the basic commands in the workshop yesterday. People want to learn more about optimization, some of the other things that you can do with Z3 that we didn't cover, but running through these real world examples is a really great idea. And what came up after on Twitter when people were discussing the workshop, we were like running through some real world ideas people could apply like Z3 to. So that's like not a bad idea either. So definitely, I mean, our internship's technically over, so maybe that's more for the RISE group, or my internship's technically over, but yeah, like great idea.
So from this workshop, like, did you see, like, since it was kind of a introduction of the new, framework to learn Z3. So did you see all the new beginners into this space, or were there actually expert users also who actually joined in and maybe they shared some feedback and stuff with you?
I haven't looked too deep into the data we got because it happened yesterday, but I did sense a mixed background of people. Yeah, there are like really beginners who have been interested in tool for so long, but never really got either the time or motivation to really get started. And maybe the learning resources for getting started is like rather scary for them. I don't know. But yeah, they came to the workshop like fresh minds, and then they really appreciated the fact that this workshop was hosted and the fact that there was a guide for them to use offline asynchronously to continue with the learning experience.
Yeah. The reason I was go on.
Sorry, go ahead, my bad.
Yeah, and the reason I asked this kind of a question was because that would have hinted me, like when we think of conducting any workshops of existing tools and big compilers and so on, like open source stuff, and then we are always confused about like, hey, people have been now using this for years, and because we care about educating this and making it more useful for people, so people are not overwhelmed by this idea of using, let's say, LLVM compiler or now MLIR and so on. So what should be the mindset of conducting these workshops? Like I thought like I would just grab some ideas from the experiences that you had this time for Z3, because Z3 has been existing around for a long time now. So having this kind of a new platform, new interactive way to learn with major improvements. Yeah. We can chat more offline also about this. Like, what were your takeaways in terms of like sharing this whole experience?
Right. What you said reminded me of a talk I recently watched. I really liked the talk. It was really inspirational, and my favorite part is the takeaway message from that talk. It was basically an interview between someone, random person, like a content creator, I think, interviewing a tenure track professor about they're in the same class, like during undergrad, but they went on to like different career paths. So one became content creator, the other became professor in, I think, politics and sociology, something like that. So this content creator asked the professor, like, what does it mean to do research? What does it mean to stay in academia? Like, when you're trying to publish, you're trying to make impact, but isn't that a slow, painful process? And the response from the professor I really loved, which is that like the reason behind why we choose to get a PhD and whether or not we stay in academia afterwards, whether or not we go on to industry or we become software engineer or we go to farm, like do farming, it all matters because we are devoting some period of time into like a very tiny area of research, trying to build excellence out of it, because we have the hope that we want to educate people in some sense. And the education itself is like a long, painful process as well. But with all the effort aggregated, to some extent, impact will be made in a much, much more scalable way. Like thinking about, that reminded me of the invention of the internet, like, you know, a couple of decades ago. Like people now have jobs such as content creators, like they publish YouTube videos on there. Before the age of internet, like who would think of that as a possible career path? So content creators don't necessarily know about the technical details behind the internet, like how networks are worked, but with the invention of the internet, they got the inspiration and they kept on like generating other creativity, other thoughts that they wouldn't have produced decades ago before the age of internet. So yeah, so that I think the education to us, whether or not we're in the industry or in the academia or on the farm, it's all brings us the reason that brings us into doing a PhD. And if we keep that mission in mind wherever we go, then one day our effort will aggregate and then impact the world in a meaningful way.
True. Yeah, I totally agree on that. Ayana, I wanted to know, like touch base on that same topic that you were talking about, applying HCI techniques in journalism, which is of your interest. Can you share some of the HCI techniques that you use, like some high level ideas, since, today I kind of picked up a few terms like iterative techniques and, doing some data analysis and so on. I would just, like to know, like what kind of techniques do you use? Are they different from, PL research or some other areas?
Yeah, so yeah, I can touch a little bit on that. Mainly the stuff that we do, or at least that I've done so far, there's like a lot of other, honestly more experimental, like quantitative stuff that you can do, but I haven't really touched a lot of that yet. Mostly what I've worked on is like interviews and like surveys as a metric of basically seeing how well your system is doing and also understanding what facets need to be included in your system. So a lot of what you've seen in this talk here. So some of the stuff we've done on the like journalism work that I've worked on is basically like a really huge, for the field, I guess, like a really large survey on what you think of like online journalism, consuming journalism, and then from there, like what facets you need to basically understand whether or not, like what helps you trust news, like what features you look at to trust news, period. Because from there you can pretty much look at, okay, these are the things that they look for, these are the things we need to support. And I think one of the things you need to make sure that you're doing when you do qualitative research is making sure that you don't like give the answers to people. So like, like we're building a system that does this, this, and this, like, okay, we need you to like give us very like specific instructions from there. It's more like pulling from the feedback that they give you, or the feedback that they give you on the process that they're working on. And so from there, something that you can do, which is like kind of the opposite direction of what we did this time, instead of like doing the interviews first and then doing a survey, or like doing something that is more like a large scale, like a interview or workshop, and then like getting feedback. You work the other way, where you take your survey data, pull a couple pieces, pull a couple individuals out, and then interview them. So we did like 20 people that we interviewed, you're basically like, okay, from there, explain some of the answers that you gave us and tell us more about this so we can make better decisions. And so those are the main things that I really like to work with, and they've like yielded some interesting results. I like the way that we've done that study at Clemson. So like that makes sense to me as a paradigm to explore these concepts and improve these systems. But yeah, that's mainly the stuff that I've worked on so far. And I'd say applying it to PL, definitely getting a sense of what actually needs to be, like Lisa was really talking about, like what do you need to actually support these people that you're working with? This is a very specialized population, at least on the journalist side. So yeah.
Sure. Yeah, cool. And for someone to get started with HCI, especially, I am very fascinated. I always, kind of knew about it from very far, but never got a chance to actually, even attend a single talk about it, but was a part of some user surveys for my friend who was doing PhD in this area, but never got a chance to learn about it. So would you like to share some of the books or papers or something, that one can get started with to learn about this?
Yeah, so some of the stuff, like from just an HCI perspective, one thing that we've talked about today was the Nielsen-Norman heuristics. And also like the Nielsen-Norman group is like what everybody in the HCI space, well, not everybody, but one of the main things that people either in industry or like academia really look to for empirical advice on how to perform user studies. So the things that we talked about were the 5 people for user studies fact. I don't know if you call it a fact, but that's like the pretty much industry standard of like 5 people, you cover 70% of the issues, like Lisa talked about, right? So that's Nielsen-Norman group does a lot of stuff there. They also talk about heuristics. So there's things like making things accessible, having help and documentation easily accessible. And then like a couple, there's like 8 other ones, the ones I just mentioned, where if you're building a website, these are the things that you really need to make sure that you include. And when you're going through and testing it yourself before you even get to the users, these are things that you need to cover, period. So folks that are building a website, I think honestly, they apply to tools as well. I did a study, sort of, not to plug my own work, but like I did a study on that for some journalism stuff, run through the 10 facets, and then you can analyze your stuff before you even get to a user. So that's Nielsen-Norman group is a really good resource for anybody looking to get started. In the PL space specifically, some things that I pulled, there's an article about why we should even, if Lisa and I didn't convince you, why PL and HCI are great to combine in general, by Sarah Chasins, Elena Glassman, and then Joshua Sunshine. I really like that. I can like send that title formally. And then something that just happened, which is going to be a good resource. It was called the PL and HCI Swimmer School, which is essentially introducing people to, I don't know if I'm right, Lisa, but combining these things like PL and HCI is fairly new as like a thing to talk about. So a couple professors put on this summer school to introduce their work and also the concept of these 2 things together. And they're going to start posting their resources from the talk in the coming weeks. And I had class, so I couldn't go to it. So I'm eagerly awaiting these resources as well, but I can send the website that they're going to start posting to, so I can drop these in the chat.
Cool. Yeah, I mean, I think I kind of agree that this area is still relatively very new, but this is moving really faster as well at the same time, which is awesome. I think before I go to my last question, I still have one more question to ask. So, usually we have had a few PhD students come and give talks in the past as well. And, it's kind of important for the other people when these videos go up on YouTube, on the LLM channel and so on. So every time, there is somebody out there, who is wanting to go to the grad school or, wanting to pursue this undergrad career. And people have a hard time figuring out how to narrow down their research, and they want to know it from the student's perspective. Sure, professors have a different, take as well. They guide in a much better way. But I think it would be, useful today to hear from you, like, as an undergrad, how did you actually started to narrow down your research areas? Because you have been exploring quite a lot,
Yeah, that's a good question. So I'd start with the fact that a lot of people, when they're starting to try and do research in undergrad, they'll sort of take anything that they can get because of their like undergrad research positions are sort of uncommon in general. Which, I mean, if you're just trying to figure out if you like research as like a thing to do that, like, go ahead and do that, that makes sense. But especially when when I got to college, I like knew I really wanted to do research. So I was like pretty confident in that decision. I would say when you're going through and looking at the opportunities, don't take whatever just kind of lands in your lap. Like think about what it is that you really want to do in the future. And like for me, I knew I really wanted to help people like make better decisions like before I even like freshman year, that's what I knew I wanted to do. And I started doing research my sophomore year. So when looking at like labs and stuff and talking to professors, I had to really not grill them, but like make sure that what they were doing was sort of aligned with my values, even though it was like I don't have like a super specific research area like I do now, even though it's not really super specific, but it's getting there. Even before I had like a better idea of what I wanted to do, making sure that it at least aligned with the core like values, and making sure and helping people make decisions was like really important for me. And then I'd also say people are really, or like undergrads especially, are really afraid to talk to professors. I don't know. I guess it makes sense. They've been through like getting their PhD. They're super like imposing maybe. But they're people that really like to talk about their work. Like you get them started, they will talk your ear off about what they're doing. So ask them questions, and also like make sure that like it's okay. That's the thing that you can do that's totally valid and fine. So I'd say definitely start there, and then from there make sure that when you get into the labs, volunteer to do the work, volunteer to write the papers, volunteer to analyze the data, not just kind of exist. And those are really good steps. And like as a professor or something, like encourage people to do that, because it can be intimidating, but also help people do the thing. Yeah.
Awesome. Yeah, thank you. Thank you for sharing this. In case anybody else has a question, please go ahead and ask one last time. Otherwise, I just have one wrap-up question for the doctor there. I think, yeah, I'll just open up my question in that case. So it's for both of you, and either of you can jump in, and both of you can also share whatever. So while we're trying to conclude this Q&A, since we are a part of this LLM Foundation, and today we learned quite a lot about the PL, HCI, and journalism techniques and whatnot. So in general, I wanted to conclude this session by taking some takeaways from both of you in terms of improving the whole compiler developers mindset. For example, we have a lot of open source compilers nowadays. Take it LLVM, MLIR, even GCC has been existing for a long time, and there are many other compilers. But the whole impression that we get from any compiler learner is that compilers are very hard. This is how people say every time. Like, oh, it's very hard to dive into a compiler, to learn how to get started and so on. Like once you are into it, then of course things get easier, as usual with any other tools and softwares. So what are the few takeaways that we can have in order to develop compilers from the HCI perspective, so the learning becomes more easy? And of course, with the both goals of helping students as well as teachers back in the school, so they can also have these open source compilers structured in a much easier way, so students can actually learn them in a better way.
Yeah, I think I can get started. I have two somewhat like concrete suggestions that also have like a higher level takeaway. So the two suggestions I would like to make is that in terms of improvements of the compiler tool itself, I think error message is a really fundamental way to drop in any like user-friendly features, improvements you can add, because that's essentially one of the very, very critical ways for the compiler to actually interact with the users. And I think there are a lot of great lessons we can learn from the Rust community. Like the Rust compiler is really famous for having most of the time user-friendly, readable, understandable error messages that really help people figure out what's going on with their program. So I think that is a really good step towards a wonderful direction that we could pursue, and I would encourage like other compilers to consider like what the experience of the Rust community. And then the second concrete suggestion I would like to make is in terms of like documentation, like in terms of how to learn about using your compiler, how to use its appropriate APIs. So one thing I think would be really helpful is to make your documentation really interactive. Whenever you're like showing code examples, it'll be great if people can just run the code and see the results. And I am aware of actually online editors of compilers, which is amazing. I think the other day, forgot who it was, but they were showing me this online environment where you could have, say, like C program on the left, and then say you want to pass it through like a very specific version of GCC and what the output would be. And then so that kind of if like this environment it's itself like a full editor standalone, but it'll be great if we could sort of utilize some of like a minimized version of that kind of environment along with the documentation that compiler is going to give. So to make the onboarding experience more engaging and interactive. And those were the two concrete suggestions I would like to make. And so a higher level, well, it's just to when you are unsure of decisions, what decisions you should make about your tool, then go to your users. And after you have made some decision, you want to go back to your users and ask if that's a good decision at all.
Yeah, I think you were referring to Godbolt, Matt Godbolt's tool.
Yeah, I think that's
Compiler Explorer.
Yeah, exactly. Yes. Yeah.
That was
Somebody was saying something.
Oh, I'm just agreeing. It was Godbolt. Yeah.
Yeah, I mean, thank you for sharing that suggestion. I think now, like as the organizers, Tanya, Anupama, Cindy, and me, we all, usually talk about this one other direction which we want to pursue as a team, and we would welcome more volunteers, who would want to make this compiler education through LLVM more accessible, more easier, and so on. So we usually talk about these. I think having gone through this kind of a talk today, I think it's time to reiterate from the scratch. This is my takeaway. Obviously, I'll discuss with the team and I would welcome more feedback from the others. I think that the kind of takeaway for me today is like it's good time to go back and reiterate on from the documentation point of view and seeing like what users actually feel about it and live watching them through this whole interview kind of an experience and seeing which kind of problems do they run into and so on, because that's the only way we can help. It's more like being a teaching assistant and watching the students making mistakes and then telling them, oh no, you don't have to do this, maybe do this, and basically learning from there and making improvements in the documentation maybe could be the first step for us.
Yeah. And then I'll also say sort of like it's great that like you guys are taking those first couple steps, because in previous experiences before even doing any like academic research, I was working as a like user experience researcher for folks that were doing compliance. And the hardest thing for like getting people to actually sort of agree with the compliance, like the front end for the compliance like platform that we were working on, was once they get past the hump of being a beginner, it's like I've made it essentially, like I understand it, like I got over the knowledge humps, like it's not that hard. It's sort of your review of the learning process after you've done it. But people that are still like in like the learning phase are like struggling, and so there's a gap between like the sort of novice stage and then the expert stage. So the fact that you guys are already eager to close that gap was great. And I think sort of a larger community-wide discussion that'll sort of like help move this along so it's more widespread, sort of like highlighting just how important and like maybe the empirical results of when we make these changes, the improvements are like obvious. And that was the easiest way for me to like, as I was like, what, a freshman, sophomore, trying to tell these people that have been in the industry like 30 years, like, hey, if we change the front end like this way, it's actually going to be great for our clients. That was very tough. But like, once they saw the results, it was like, okay, we believe in her, and then we'll like go ahead and make these changes. And also like helping people make changes to the documentation, like as they do them, as opposed to like, we've done it, and then we have to like write about it, which is super hard. and what like Nikolai was going through, why he pulled us on. And then also I'll say he's been amazing at like incorporating all stakeholders into this process. So pulling people like us on, talking to his his colleagues in academia of like, hey, like I have people coming in to like help me like improve this for your students, and pulling all of these stakeholders in and being really supportive of the entire community. Because like if you ask a question on Z3, the likelihood that he'll answer it in GitHub discussion is like major. Like being involved in the community, being involved in the answering questions, sort of a community shift that you need to make, but amazing steps that you can take. So
yeah, thank you. This is actually very great and a very good reminder for anybody who pursues in this direction where they want to make learning easier and better for everybody. So yeah, thank you so much to both of you for the talk today. And thank you to all our attendees who joined in. And I hope you all kind of, took some nice takeaways.
Yeah, thank you so much for a wonderful opportunity.
thank you for having us.
Yeah, thank you so
Thank you.
much.